Hey, g'day, it's Prezzo. Welcome back to my workshop. This is episode 3 of building a rear tool post for my Colchester student lathe. I'm building this specifically for taking a parting off tool. And in today's episode, we're going to make the actual clamp which holds the T-type parting tool blade in place. And we're going to try it out in the lathe and see if it lives up to the hype. Now, there is a playlist. I'll put a link to that up above there now. But before we get into the machining, I'm going to show you a new sticker. We're going to get it up on the door and we're going to talk about where it came from. Now, today's sticker comes from Alberto. Now, he lives in Italy and he's got a home workshop very similar to mine. In fact, he owns a Colchester Bantam lathe and a Sieg SX3 milling machine. Now, I've got a Colchester student lathe and I've also got a Sieg X3 milling machine that I converted to CNC. So if you like what I do in my home workshop, you'll love what Alberto does. And it turns out that Alberto is a very passionate wine drinker, as am I. And he sent me a list of Italian wines that I can casually ask for next time I'm in the Italian restaurants and make it sound like I know what I'm doing. So let's get his sticker up on the door here. And I'm going to show you on the map where he lives. So I think we're going to put him just underneath Carlem. And I am running out of room on this door unless I go down very low. Okay, so that's his sticker. Let's go and have a look on the map to see where he lives. So this is Alberto here. He's just east of Milan, a very, very pretty part of Italy. And I always do this thing when people send me a location, I check on Google Maps to see what sort of landscape there is, what sort of architecture is in the district, and what the cultural scene is like. And Italy is one of the places that my wife and I dearly want to visit, and we're hoping that, depending on how things play out with COVID and the war in Ukraine, that we'll be free to travel again, especially that part of the world. Now, I want to show you some other places that came in the last couple of months, locations that people have sent me, and I pinned them on the map, so let's have a look at some of the highlights. So this blue one here is Mexico City. That came in a couple of months ago. Just recently got one from Poland, a place called Lodz, L-O-D-Z. Hope I'm pronouncing that correctly. I think that's our first. I think that's the first one in Poland. Okay, over here in the Asia Pacific region, I got another one in Taiwan. This one, a place called Taichung. Hope that's correct. Now here we are in Australia. The place we're looking at today is called Bathurst, and it's just west of Sydney, up in the hills, and it's the home of the Bathurst 1000, a very important race in the V8 Supercar Challenge here in Australia. And Peter Brock is probably the most well-known racing driver who raced in that series of events. And he sadly passed away recently, but he was also called King of the Mountain because of his dominance in that race here in Australia. Here we are on the west coast of Australia, and just north of Perth there's a little place called Kinross. It has some beautiful beaches. In fact, the whole of that west coast of Australia has some truly stunning beaches. Here we are in Argentina, Buenos Aires. If you want to get all remote, let's go up here to Dead Horse in Alaska. I love the name. Check this out on Google Maps. There's like a million lakes there. It's right on the coast. Not a lot happening there in terms of architecture and so on. But if you're into solitude, that'd be the place to go. So from Dead Horse, let's come down here to Whitehorse in Yukon. Now, by contrast, Whitehorse is very, very pretty during the summer, I imagine. I'd say in the winter, it's probably, well, white. Here we are in France, a place called Brittany, and my wife and I did a massive road trip from Brest all the way across to Germany, and we travelled that entire coast. The person that sent me this location wasn't specific, and Brittany is quite a large area, but I put it on the coast there because it's really pretty. And down here we got another one. This is a place called Porto in Portugal. Here's another first, Reykjavik in Iceland. Now, I did update the map with lots more locations just today, and if people send me that location, I'll make a note of it on a list, and when I get the map down, I'll put more pins in there. So if you didn't see yours, rest assured it's updated and it will be there. Now let's have a close look at what's on the bench and get started. This is where we got to in the last episode. I finished off this large steel riser block here, and all I've done since then is I've cleaned that up and removed all the machining marks from that. I've done the same on this base part here. This is made of a material called Durabar, or it's a continuously cast iron product. It's essentially malleable iron. Now, a lot of people question why I had used that material. The simple answer is that there was an Australian supplier who could supply the correct diameter and he would cut it to length for me. So I just wanted to try out malleable iron just to see how it machined, and it was beautiful stuff to work with. And I didn't have any steel that size, so that's why I use this Durabar. Now this is the part we're going to be working on today. This is the same steel that the riser block was made from. It's a fairly hard steel, but nice to work with. And we're going to put a lot of features in this to hold this high-speed steel blade here. Now some people ask why I didn't just fit the high-speed steel blade directly to that riser, and the answer to that is that I want this thing to be versatile, so I can fit a high-speed steel blade on this side, and on the other side I can fit, say for example, an insert type parting tool, and that allows me to part off soft materials like brass, aluminium and free machining steels with the high-speed steel. But for harder materials I can flip this block around and use the insert holder. So with this piece of stock here, I've just machined this to the correct overall dimensions to make that part. So let's head over to the mill and start putting features in this little bad boy. I've just blued up that piece of steel stock, and I've scribed some marks on there, so I've got some visual references when I go to machine all these parts. And of course I've got the mock-up here just to remind me of what I'm doing. So I've made a slight change with this part. There's no shoulder on the bottom of this part at the moment, but I'm going to add one on this one. And that way I've got two surfaces that butt up against the face of the riser block, just to ensure that it keeps square and plumb and all that sort of stuff. So I'm going to go ahead now and I'm going to edge find the back face and the right hand end, and we'll zero out over that corner, go ahead and mill those features. Got a 6mm edge finder here. I'm just going to touch off against this right hand end and the back edge, and then I'm going to bring the 0 point to 3mm off each one of those edges. So I'm using a 12mm cutter, and I want the cutter to be touching or tangent to that back edge and that end. Let's do that. So what I'm going to do now, I'll offset 3mm in Y. And we'll zero there. And we'll zero there on X. So that will put my cutter right on the very corner of the stock, and I worked out all my offsets from there. Alright, I'm just going to come back to 0, 0 and I'll show you where we're at. So it's a bit hard to see with the cutter stationary, but that's where I'm at. And now we're going to rough out the tenon, that's this part here, that will fit into the tool block. Alright, according to the DRO, that's correct now. So I'm going to take this out and deburr it, because that's all the features finished on that side. Try it in the block, see how it looks. So there's the finished part, and that's going to fit into the riser. And I've made a slight change to the design. In the 3D printed mock-up, this bottom surface here was completely flush, and what I've done now is I've added a shoulder underneath there. And the idea is that when you put that into the groove in the riser, it pushes hard in against the face, the vertical face, and then the set screws just used to hold the tool that way to stop it sliding in and out, but it also holds it down tight against the bottom of that groove in the riser. And I've got 1.5 millimeters of movement vertically, so I can adjust or fine-tune the position of the tip of the tool relative to the center line of the lathe. So what I need to do now is machine the features that take the parting tool blade itself, and it's a series of grooves, and we've got to put some set screws in the top to pinch that down onto the blade. I've just clamped the feature that we just made in the vise, and now working on this groove here. So the groove itself is 12.12 millimeters wide, using a 12 millimeter diameter cutter. It's only a very shallow groove, so I'll just run one pass through the stock at full depth, and then we'll just offset the 0.06 either side of center. That puts the slot at the correct depth, but it's still a bit too narrow, so I'm going to take another pass and we're just going to sneak that out till it just fits the width of the parting blade. That last pass was just 10 microns, and that is just starting to fit in there. But I think what will happen is that when I slit this, it's going to open up a little bit, or at least I'll be able to force it open enough to get the blade in there. The next job here is to cut this slot, and this is to allow the top of the tool holder to pinch down onto the parting tool blade. So I've got a 1/16 slitting saw, and I'm just going to use the DRO to do all my offsets here. The total depth of that slot is 12 millimeters from this top edge here. We'll do that in a couple of passes, and I lay awake all night trying to figure out how I was going to hold this blank, this tool holder blank here in the vise and still have room for the overhang on the slitting saw arbor. And I thought, you idiot, you can just use the existing riser that you've already got to clamp it all. So that's what I'll do here, and then we can go ahead and drill and tap the 3 holes that will allow that to pinch down, and that part's done. Well, that was the last pass through there, so I'm keen to see whether that slitting operation has allowed this plate on top to move up at all and to give us a clearance for the blade. So I'll grab it and we'll just check that. No, not at all. No, maybe, just marginally. I'm going to have to take another pass off at least one of these edges here just to give us the clearance to get this in easily. Don't want to open up too much, we just want it to be enough to slide in and then we can pinch that down. I'll go ahead and we'll drill the 3 set screw holes. That's the first of 3 holes that I need to drill for these screws. They're 28mm apart. And what I want to do is to spot drill all 3, then change out for the tapping size drill, do all 3 and so on. One of the really cool things you can do with Touch DRO is you can add points on the fly. So I'll show you what that looks like up here. So here on the interface you can see the offset that I've used in X, which is 6mm from the edge, and I've set the DRO to the center position of 0. So what we're going to do now is just add a point. That point is now positioned, and you can see it's 0 to X and Y, and then we can offset 28mm for the next hole. So let's do that. And I'm going to add another point there. So I'm going to spot drill that one, and then we'll offset 28mm, or a total of 56 for the 3rd hole, do that. And then I can go back and find all 3 of those points just by tapping on the screen over on this list here in the workspace. And yeah, if you're wondering about that noise, that is my rotary phase converter, and it's as noisy as all get out. And everybody always comments on it and said, what is that horrible noise? Well, that's what it is. I'm going to try and do something about it in the new year. I think it's just the motor in the phase converter that's not balanced very well. But the actual unit, the electronics in it, don't make any noise at all. It's just the motor. Okay, so now we're going to offset a total of 56 for the 3rd hole. That one there. So you can see the 56 in Y there, so I'm just going to add a 3rd point. So now I can go back and I can find all 3 of those points again really quickly and just swap out the tools and drill as I go. This shiny screen is a bit of a problem, but you can see here I've just drilled the 3rd hole and I want to move back to the middle hole. Well, that's actually point 1 on my list. So if I just tap point 1 up there, you can see now I need to move back 28mm in Y to get to the next hole. So let's do that. So we should now be directly over the center of the next hole. I just started the threads in all 3 of those holes, so I'll just finish that off camera and then we'll try it out. Just deburred that slot there, and I tried the tool bit in there and there was no way that was going to fit. I took it back over the mill and I took about another 0.04 millimeters off that 3 millimeter clearance slot where the thickened edge of the blade will go. And you can see now that that slides in there really nicely. It's sort of not loose at all, but when I tighten these M5 socket head screws down, that clamps that blade really securely. I don't think there's any way in the world that's going to come out of there. So what we need to do now is take this next door, put it on the surface grinder. What? Oh, stop sniggering. It is a surface grinder, look. Just doesn't have a motor, that's all. Well, here's the whole thing assembled on the lathe now. So I've given this a thorough clean up, I've tightened everything down, I've fitted a steel washer underneath this M12 bolt. At some point I will make a hardened steel washer to go underneath there. And I will do a Parker phosphate coating on all of these parts. Just in the last couple of days these have started to corrode, so it does need some sort of protective coating on it. Now, I guess the thing you want to know is, does it actually work? Well, let's try it out on this big chunk of carrot. Well, I think that's definitive proof that this works, so what? You're not convinced? Try something harder. What's harder than carrot? Okay, well, I guess it's time to get serious now. To be honest, I've been putting this off. I'm still not absolutely confident in this tool. It's going to take a bit of time to get used to it and see what its capabilities are. So this is a piece of free cutting aluminium, and I'm going to be cutting this at 760 RPM. And approximately 2 thou per revolution. Now, a couple of caveats before I start. This is a fairly new 3-jaw chuck, but it is a Taiwanese chuck, and I'm using this one because the jaws are less likely to be bell mouth than they would be on my bigger chuck. And if you're trying to part off work and you get a lot of stick out from the chuck jaws and they're bell mouth, you're going to run into trouble. Now the other thing is I've got 20 millimeters of stick out on the tool itself, so the maximum diameter I can do in this configuration is 40 millimeters diameter. And I'm going to be using WD-40 as a lubricant on this material. So let's give it a go and see what happens. What's the worst that can happen? Smash the tool. Well, absolutely no chatter, which is the good thing. I'm still very reluctant to just let that cut without putting some sort of lubricant in the cut. But let's try something else. Let's try some brass. This is sort of like the biggest chunk of brass I could find in my scrap. It would be nice if I could get a little more grip in the chuck itself, but we'll see how this goes. So I'm going to do this one dry, no lubricant, same speed and feed that I used for the aluminium. Does leave a funny pattern on there, not sure what that's about. But again, no chatter, no hesitation, no sign that it was wanting to seize up or grab. Let's try some cast iron. This is a chunk of cast iron that came out of one of those exercise weights. It's not very good quality cast iron. I've slowed the lathe down this time to 315 RPM. Same feed rate as I used for the brass though. And I'm going to do this dry once again. There's a lot of free carbon in cast iron, so putting lubricant on doesn't necessarily help. Now, I must admit, a bit nervous about this one. We'll see how we go. Alright, piece of cake. Same funny pattern in there. And by the way, I'm using power feed for all of these cuts, and that's something I would never do before when I was using the old front mounted tool post and the conventional parting tool. And I believe that using the power feed is actually a good thing, even though I didn't trust to do it before. I think what used to happen when I was hand feeding was that sometimes you'd hesitate, you'd hear something and you'd sort of slow down, then you'd speed up again, and that gave the tool an opportunity to grab and dig in and pull forward. But I think using the power feed, you've got a more consistent feed rate. Okay, let's try some steel. Okay, this is a piece of free cutting mild steel. This is roughly 32 millimeters diameter, or 1.25 inches. I'm running at the same speed of 315 RPM that I used on the cast iron, and with this one I'll be using flood coolant. Same feed rate that I've been using for all of the parts so far though. I was just looking at the chips that had formed with cutting all that material, and certainly on the steel it's formed really nice tight curly chips. And the good thing about having an inverted type tool is that the waste material, the swarf and the chips, can simply fall out the bottom of the cut. Also the coolant, if you're using flood coolant, gets a chance to get right down into the cut and into the cutting edge of the tool. Now at some point in the future I will fit an insert type tool holder to this rear tool post, and that will give me an opportunity to work with harder materials and use higher speeds. And also I'll choose something that's got a wider cutting edge so I can get more stick out and reach deeper into larger diameter stock. But for the moment I'm super happy with the way this has turned out. Power feeding a parting tool blade into steel in particular is something I would never have done before, and you can see with the cut off pieces that I've got here, it's all cut really nicely. So I'm very, very happy with that. Okay, let's finish up here now. I'm going to talk about what's happening in the next video. Well, I hope you enjoyed that. I certainly enjoyed making this tool, and I learned a lot along the way as well. You will see this tool being used in future videos. What I need to do is to get used to it and work out what its capabilities are. Now that may mean smashing a tool or two, and the only way that you can actually work out what the limit is with you know, the cutting speeds and feeds and stick out and you know, sort of configurations would be to actually push it to the extreme and then sort of say, well, that's the limit, that's what I can do with it. But it's certainly given me an opportunity now to do more with my lathe. I can feel more confident about that process that I used to hate prior to this, and that's a good thing. So I'm going to bring in a bit closer. We'll look at some of the parts that are on the bench here, and then we'll finish up. Here's an example of some of the parts that I cut off over at the lathe there, and I just wanted to talk about this one in particular. And if you can see that pattern that's on there, that's evident on all of the parts regardless of what material I cut. So there's the steel, probably the only one you don't see it on. Oh no, it's on the cast iron as well. But I'm starting to wonder whether that's an indication that I've got too much end float in my headstock spindle. So if anybody knows what's causing that, and if you've seen it before and you've been able to fix it, and you can let me know in the comments, I would appreciate it. Okay, let's have a look at another project that's coming up in the next video. This is an aluminium pallet that I've made for my rotary table. Now I've got a job coming up where I need to use this, and I have to hold parts down on the surface of this pallet. So I needed a set of clamping hardware that's specific to this pallet. Now this one takes 8mm dowel pins, and it's got M8 threaded holes in the bottom half of each of those holes. So all of this hardware here is designed to go into those M8 threaded holes. Now a while ago I was watching a video by Clickspring, don't know if you caught it, but he made a set of Mighty Bite-like clamps, and the type he had made were the hexagonal style of clamp, and they've got an eccentric headed screw, so that as you tighten the screw it pushes the clamp into the side of the stock and holds it down against the pallet. Now I thought, yeah, I could use them, and I decided to make this style of clamp instead though. So this is the one that has a step in the end of the clamp, and this allows you to hold a part in that step there. So imagine this is just a bit of raw stock that would fit into the step, and then when you tighten this, what will eventually be an eccentric headed screw, it will push this piece of brass into the side of that stock and hold it firmly. Now I've done engineering drawings for all of these parts, and you'll see these parts being done in the next video. We might do the Parkerizing too if we have time. So join me for that, should be interesting. And it's Prezzo signing out for now, and I'll catch up. Oh, and I must apologise for the Macca reindeer video. Don't know what happened there, probably a bit too much Christmas wine perhaps, but yeah, it won't happen again. Anyway, Prezzo signing out, catch you on the next video. Cheers.